Hi, I'm John Williams. I'm Professor of Information Engineering in the Department of Civil and Environmental Engineering at MIT. And my background is basically in physics. I grew up in the UK. I'm from Wales, which is basically steel and mining. So I ended up in Oxford University, played rugby there for Oxford. So I got an Oxford Blue, they call it. And we happened to beat the Springboks, who are the world champions at the moment in rugby. But that was a long time ago. And so my journey went through UCLA, where I studied physics and basically got fascinated with how we could simulate physics. And I ended up going back to Wales and did a PhD in Swansea University. And that was the place where they invented the finite element method. A guy called Zenkovich, Professor Zenkovich there, was the world kind of renowned in finite elements. And so I became embroiled, if you like, and fascinated by simulation. And after the PhD, I went into industry for 8 years and did 2 startups, one in Colorado, and we basically were simulating the oil rigs up in the Arctic. So I spent some time in the Arctic, which is a place where the one thing you want to do is get out of there. It's great for about 3 days, and then it becomes pretty hellish. So I spent time on offshore rigs there, and we were simulating in our company the impact of ice on offshore rigs. And the big thing about ice mechanics is that it's not continuous, that you've got basically most of mechanics is based on this continuum theory, and the assumptions of continuum theory don't hold for ice, that you've got it fracturing, you've got pieces of ice, and the key problem with the offshore rigs was that the ice would ride up on the sides and possibly take the deck off. The ice was about 13 foot thick. So these are not small pieces of ice, you know, this is the height of a room. And when they hit you, they shake the whole rig. My first night on the rig, I was really scared. It was shaking, it was like a leaf. But the structures, they've done a pretty good job, I guess, of designing them because they survived. But that's how I became embroiled in or fascinated by non-continuum mechanics. So this is where you've got pieces like you might have a soil or sand or powders, so drugs, for example. And in the company, we invented something called the discrete element method, which is basically lots of particles, and the trick is how to figure out how they interact. So computationally, it's quite expensive, but we made we developed a commercial code actually called Sea Ice that was sold to the oil companies. And so after that, we sold the company. Didn't make a lot of money, had lots of shares that we could paper walls with, but eventually they came good. But then I applied to MIT for a job in MIT, and I became a research scientist here. So that's how I ended up in MIT. That's the short story.